Okay, so how do I solve a percent problem? That's what we're going to be talking about today. So there are 4 ways to solve a percent problem, and we have to choose one that makes the most sense. Either we have to draw, we divide to find our decimal, then change it to a percent, we set up our proportion, or we check for reasonableness. Okay, I'll leave these up in the slides for you guys to see, and there's also going to be a poster in the class for you guys to look at. So now if I move on to our example, or at least in this part, the percents, we're gonna use the different methods, okay? So one of the methods was to use reasonableness. So what percent of the model below is shaded? So if I look at this, let's count how many boxes we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 equal boxes, okay? Remember how I said equal. So I have 10. Let me write that right here. Out of, right? 1, 2, 3, 4, 5, 6, 7. So I have 7 out of my 10 boxes, 7/10. Okay. If I'm using reasonableness, if I cut this in half, so half of 10 is 5. 1, 2, 3, 4, 5. I know half of 100 is 50%. And this is more than 50%, because see how I have 2 more shaded? So that means this should be more than 50%. So if I move this, right, if I change it to a decimal, and remember how I told you guys that it's important for us to say our decimal places correctly because it's going to help you with fractions? This is the instance where it's going to help you. 7/10 is actually equal to 0.7, because 0.7 tenths. So then I can add a 0. It still won't change the value, okay? Because I'm talking about the 7. The 0 means kind of nothing. I just know it's 0.7. It's 0.70. So in order to check that this is correct, so I can show you guys, I'm going to use division. So 7 is my top dog, goes in the house. 10 gets kicked out. 10 cannot go into 7, so this is a 0. But I need to add a decimal and a 0 so I can continue. And don't forget to bring up your decimal. So now 10 can go into 70 7 times. 10 times 7 is 70. I subtract, I get 0. And then I can add another 0, and I drop it down. 10 can go into 0 0 times. 0 minus 0 is just 0. Okay, so now I'm going to show you guys my cool trick that I love to use, which is Dr. Pepper, which is my favorite drink. Dr. Pepper. This means decimal to percent. So all decimals have a decimal right here, and percent have theirs at the very end. So I'm going to leave it like this. So I'm going to match my decimals. So if I'm going to use 0.70, if it's first a decimal, I want to change it to a percent. All I have to do is move the decimal twice to the right. So now 0.7 or 0.70 or 0.7 tenths, 0.70 is equal to 70%. So this one is 70%, and we did figure out that it was more than 50%. So now the next one, shade the model for 40%. This one we can cut it into 10 equal pieces. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know they're not that equal. That's my bad, but it's hard with the mouse. So this ideally should be 10 equal pieces, okay? To represent 40, remember, out of 100. So I have 10 out of my 4, right? I have 40%. So part 1, 2, 3, 4 over my total, which is 10 equal pieces, should give me 40%. Okay, and now the last thing that I'm showing you guys right here is this shaded 70%? Why or why not? It is not, because how I emphasized before, I need equal pieces. This is not equal pieces, so this is not 70%. I cannot figure that out at all. Okay, so I cannot figure that out. It needs to be equal pieces.